For decades, scientists stared at the sun and couldn't explain one of its strangest secrets. Its surface burns at nearly 6,000 degrees, but just above it, the air suddenly explodes to millions. How can something farther from the fire be hotter than the fire itself? This paradox, known as the coronal heating problem, baffled solar physics for nearly a century. But now, a breakthrough experiment and new solar data may have finally cracked the code. The answer lies in invisible magnetic waves dancing across the sun's corona, waves that silently heat it from within. Today, we'll uncover how these waves work, why this discovery changes everything, and what it means for the future of solar science. 1. The century-old puzzle no one could solve. For decades, scientists puzzled over a bizarre fact about our sun. Its surface, the photosphere, glows at about 5,800 Kelvin, yet the layer just above it, the corona, blazes at over 1,000,000. In some regions, temperatures even soar beyond 20 million Kelvin. How could something farther from the source of heat be so much hotter? This contradiction haunted solar physics since the 1940s. Theories piled up: nanoflares, turbulence, waves, magnetic reconnection, but none could fully explain where the missing heat came from. Until now, the breakthrough came when plasma physicists and solar observers joined forces. They recreated the sun's outer layers inside a massive plasma chamber on Earth, a lab environment where magnetic fields and ionized gases behave just like those on the sun. There, they tested how waves of magnetic energy, known as Alfvén waves, travel through plasma that mimics the corona's low density. And what they found shocked everyone. When these waves travel upward and hit regions of different magnetic strength or density, they reflect, collide, and create turbulence, like crashing ocean waves. That turbulence acts like friction, converting magnetic energy into heat. And the numbers matched perfectly, as if scientists had finally recreated the sun right here on Earth. For the first time, this provided tangible, experimental proof of how the sun's outer atmosphere could be superheated, not by explosions, but by invisible magnetic waves rippling through space. It bridges the gap between theory and observation, solving a mystery that stood unsolved for nearly a century. 2. The hidden engine inside the sun. To picture it, imagine the sun's magnetic field lines as invisible strings stretching far into space. Along these magnetic highways, plasma waves, oscillations of charged particles, constantly travel upward from the surface. These are Alfvén waves, and they behave much like the vibrations of a guitar string when plucked. Now, think of it like this. Every note the sun plays on its magnetic guitar strings sends out invisible ripples of energy, ripples that heat the space around it to unimaginable levels. In regions called coronal holes, where magnetic field lines are open, these waves travel freely into space. But when they encounter sudden changes in density or magnetic strength, part of their energy bounces back toward the sun. The upward and downward waves collide, creating a storm of turbulence. That turbulence is the key. As the waves interact, they twist and distort, transferring energy directly into the plasma, heating it to millions of degrees. In the lab, scientists measured exactly this effect, finding that the energy converted to heat was more than enough to explain the real corona's extreme temperatures. When you think about it, the sun doesn't explode to stay hot. It hums, constantly and silently. It's like the sun has an internal microwave oven running 24/7, powered purely by its magnetic field. Even more fascinating, this same process may explain how the solar wind, the constant stream of charged particles flowing through the solar system, is accelerated. The regions where this wave heating occurs are the same places where the fast solar wind originates. So these magnetic waves aren't just heating the corona, they're shaping the very flow of space around us. This isn't just theory anymore. It's real physics, real data, and real proof that we can finally grasp the hidden rhythm of our star. 3. Why this discovery changes everything. But this discovery isn't just about solving a cosmic puzzle. It could protect our planet. The sun's corona is where the most violent solar events begin. Flares and coronal mass ejections that can damage satellites, power grids, and even endanger astronauts. Understanding how the corona is heated means understanding how energy builds up and releases in space, the foundation of predicting space weather. With this breakthrough, scientists can refine their models of the sun's behavior. By knowing exactly how magnetic waves transfer energy, we can better predict when and how solar storms might strike Earth. It's a leap forward in safeguarding our increasingly space-dependent civilization. But it doesn't stop there. This mechanism could be happening across the universe, on countless stars just like our Sun. If magnetic wave reflection and turbulence can superheat the Sun's plasma, it's likely a universal principle of stellar physics. In other words, by solving one mystery about our own star, we might have uncovered a secret of all stars. And the impact extends to future missions. Now that we know what to look for, spacecraft like NASA's Parker Solar Probe and ESA's Solar Orbiter can directly hunt for these wave interactions and turbulence. Every new measurement brings us closer to mapping how magnetic energy transforms into heat and motion. Most importantly, this breakthrough proves something bigger, that when laboratory physics meets space observation, we can finally recreate the universe's wildest phenomena right here on Earth. That partnership between Earth and space, between human hands and cosmic forces, is rewriting the future of astrophysics. For the Sun still has secrets. For decades, the Sun's million-degree corona defied all logic. Now, thanks to cutting-edge experiments and space missions working together, we finally have a compelling answer. Magnetic waves reflecting and colliding inside the Sun's open fields are converting their energy into heat, powering its blazing atmosphere. The Sun, our oldest neighbor, is still teaching us how little we truly know. And with every new discovery, we step closer to understanding not just our star, but ourselves. If you enjoyed this video, please like, share, and subscribe for more space updates. Your support means the world and keeps our journey going.